Inverse normal distribution. In the previous lesson, we have learned how to calculate probabilities in a normal distribution. This was represented by the area under the graph. In this lesson, we will do the inverse, when we know the area under the graph, but we have missing values. We call this the inverse normal distribution. We will use our calculator to work this out. For this, we need to know the area, mean, and standard deviation. In this video, we will do a demonstration with both of the recommended calculators. Example 1. X is normally distributed with mean 80 and variance 144. For part A, we need to find the value of A, which will give an area under the graph equal to 60%. On our Classwiz calculator, we go to Menu, press 7 for distribution, then press 3 for inverse normal, then type in the area of the left tail, 60% or 0.6, which is shaded in pink on our sketch. We also need the standard deviation sigma. This is the square root of the variance. Square root of 144 is 12. And finally, the mean, mu, 80. This gives us A, the answer that we are looking for. 83.0, two free significant figures. On our graphical calculator, we go to Menu, then 2 for statistics. Then we can see on the screen dist. This represents the distribution, so we press F5 to select this. Then F1 for normal distribution, and F3 for inverse normal. Here we have two options for the data entry. We have to make sure that we select F2 for the variable. The graphical calculator is more advanced, so we can choose whether we want the left or right tail. And there is a third option called central that gives the symmetrical values around the mean. In this example, we will need the left tail. Then for the area, we type 0.6, sigma 12, and mu 80 to get the answer that we need. Part B. Find B such that the probability of X larger than B is 0.3. This represents the right tail, the upper 30% of the area, as shaded in purple. For the remaining of this video, we will only use the Classwiz calculator, because now you know how to reach the inverse normal on both of the calculators. On this calculator, we need the left tail for the inverse normal. This is 70%, 100% minus 30%. So we will type in for the area 0.7 or 70%. The standard deviation and the mean stay the same as in the previous point. This gives us the answer for B, 86.3. Part C. Find C such that the area enclosed by 70 and C is 40%. We need a complete left tail for the inverse normal, so in order to find out the probability or area under 70, we will use the normal CD, normal cumulative distribution function on our calculator. See the previous lesson for more practice on this. For the lower value, we have negative infinity, as it's an asymptote, so we will type in a very large negative value, such as -1,000,000. For the upper value, 70, standard deviation 12, and mean 80. This gives us the probability 0.20232, and so on. Now we have a complete left tail below C. This is 60.23%. When we write in the value for the area in the inverse normal distribution, we have to make sure that we are writing as accurate answer as possible. So I'm going to use the answer button that stores the exact value. We can also use the number rounded to plenty of decimal places. We don't want to round the middle answer too early because we lose the accuracy of our final answer. After we completed these entries, press equal, and that will be 83.1. The masses, Y grams, of some chocolate bars are modeled using a normal distribution. Y is normally distributed with a mean of 40 and variance 9. 20% is the upper tail, shaded in pink, therefore the lower tail is 80%. Using the inverse normal function on our calculator, we type in the area 0.8, standard deviation is square root of variance, square root of 9 is 3, and the area is 40. Press equal to get the value of Y. This is 42.5, two free significant figures. For part B, find the interquartile range of the masses. For this, we need to find the lower quartile and the upper quartile. Below the lower quartile, the area is 25%. Below the upper quartile, the area is 75%. So we need two calculations for the two separate areas with the inverse normal function on our calculator. Inputting the values gives us the lower quartile, which is 37.9765, and so on. Inputting the values for 75% area gives us the upper quartile, which is 42.0234, and so on. The interquartile range is upper quartile minus the lower quartile, and this is equal to 4.05 to 3 significant figures.